Hello everyone and welcome back to our channel. And in today's video we'll be talking about implicit differentiation. So far in your subject you have learned some of the differentiation rules like the simple power rule, the constant rule, the sum and difference rule, the product and the quotient rule, and the chain rule. And this time we'll be having this implicit differentiation in which this technique will work in some equations, and this technique also will work especially if you have given a relation and not specifically a function. Okay, so as a review, when we are differentiating a function with respect to x, then it means that the variable that is varying is x. Okay, so whenever you encounter dy dx, it means that we are differentiating the variable with respect to x, okay, and not with respect to y. And when you differentiate terms involving x alone, you differentiate as usual because there is only one variable x. But if ever there is a combination of other variables except x like y, z, t, or s, then we'll use implicit differentiation. So when you differentiate terms with x and other variables involving like y, then you must apply chain rule here because you are assuming that y is defined implicitly as a function of x. Okay, you will understand this better if we have some examples. So the first two examples here, take note of the first example. The first example says find the derivative of x squared with respect to x. Okay, so the given function is x squared, quadratic function, and the variable involved here is x, and you are also differentiating with respect to x. So we will apply here our ordinary differentiation process because there is only one variable involved, and that is x. So the answer here is 2x. Okay, so the derivative of x squared is 2x. Okay, and in the second example also, notice that we are differentiating with respect to y, and the variable involved in the function is also y. So you will have here ordinary differentiation process, which is the answer is 2y. Okay, that's very simple, right? Okay, while in the third example, take note of the third example. The third example is you are differentiating with respect to x, but the given function, the variable involved is y. So the answer here is not 2y and it's not 2x, but we will differentiate implicitly y squared because the given function is in terms of y, but the direction is we will differentiate in terms of x. So the answer is 2y, then you will have dy dx. Okay, so that is the answer. We are using here chain rule because 2y is the derivative of y squared, but we need to multiply that again, the derivative of y with respect to x, which is implicit. And yeah, that's it. In number 4, you have here two terms, a binomial. The first term is x, the second term is 3y. Okay, and the instruction is we will differentiate in terms of x. So if we will differentiate the expression x plus 3y, then you will find the derivative of every term. That is sum rule. Okay, sum rule. So what is the derivative of x with respect to x plus the derivative with respect to x of 3y? Okay, so here in the first part, the derivative of x with respect to x is 1, of course, plus the derivative of 3y with respect to x is 3 dy dx. Okay, so that's the answer. The derivative of x, I will repeat, with respect to x is 1, and the derivative of 3y, take note, this is with respect to x, but the given is in terms of y. So we will differentiate as usual 3y, but we will write dy dx. Okay? Okay, good. Now, if you would like to continue this one, then you can continue this one. Like for example, this will be equal now to, because the instruction is dy dx. So you will have here, let's say 3 dy dx is equal to -1 if we'll transfer that on the other side, and then this will be equal to, how do we get rid of this 3 from dy dx? Okay, so 3 dy dx is equal to -1, and we will divide this by 3 so that we'll be left on the left side with dy dx only, and the answer is -1/3. Okay, so this is now the derivative of y with respect to x of x plus 3y, -1/3. Okay, so here are some important remarks when you are using implicit differentiation. So differentiate both sides of the equation with respect to x. If the given is an equation and it's not a function, then you may consider these remarks. So differentiate both sides of the equation with respect to x if the instruction is dy dx. Then separate the terms with dy dx on one side of the equation, and on the other side you will have the terms without dy dx. Okay, so on one side you will have terms with dy dx, and on the other side terms without dy dx, and then you will factor out dy dx if it is factorable. Then you will solve for dy dx and then simplify. Okay, I have here more example. For example, here in number 1, instruction is find dy dx for the equation x squared plus 4y squared equals to 4. Okay, so we will apply here implicit differentiation. So the given equation, you will differentiate, so you will have here d dx of x squared, okay, plus the derivative of 4y squared with respect to x, because the instruction is with dx, and then you will differentiate also with respect to x this constant number 4. Okay, so what is the derivative of x squared with respect to x? So that is very simple, 2x. Okay, however, in the next term is 4y squared. The variable involved is y, but the instruction is will differentiate in terms of x. So we need to apply here chain rule. So this will be the derivative of 4y squared is 8y dy dx. Okay, and the derivative of 4 with respect to x, that will be 0. That is a constant. The derivative of the constant is 0. Okay, so we have a binomial on the left side, and 8y dy dx is the term with dy dx, and 2x is the term without dy dx. So we need to separate them in an equation. So I will retain here on the left side 8y dy dx, and then I will transfer this -2x on the right, this 2x on the right side, which will become -2x. Okay, and by this time, what shall we do to get rid of this 8y so that we'll retain dy dx only on the left side? So using some algebra, you may divide this one, both sides of the equation, by 8y. Okay, so this will cancel out. So the remaining will be dy dx. And on the other side, you may reduce this 2 and 8. They're divisible. So you'll be left with negative x over 4y. That is the answer. So dy dx now is equal to negative x over 4y. So far, so good. Okay, so please take your time. If you encounter some problems, you may replay the video and pause for a while and work with it. Okay, I have here another example, and this example is an example of a unique problem because it says you will find dy dx in two ways. In other words, given one equation, you will have two solutions because the instruction is you will find dy dx in two ways. Okay, so solution 1, I will write here solution 1. The requirement is dy dx with respect to x. So I will rewrite first the given equation. So I will rewrite this one in terms of y. So x squared y equals to 4. I will write this one as y is equal to 4 over x squared. I have rewritten the equation in terms of y. Okay, and what's next? dy dx. So what is the derivative of y with respect to x? And I will find the derivative of 4 over x squared with respect to x. Okay, so obviously the derivative of y with respect to x is dy dx. Okay, and the derivative of 4 over x squared with respect to x is what? What rule do we apply here? Do we apply quotient rule? I think it's not quotient rule, but there's another way to do this. You may pause the video for a while and think for a solution. Okay, so my technique is very simple. I will rewrite this expression. Okay, I will rewrite this one as, let's say, 4 times 1 over x squared. Do you agree that I could rewrite 4 over x squared as 4 times 1 over x squared? Yes, of course. And I could rewrite this further as 4 times x raised to negative 2. This step here is not a calculus solution. This is only an algebra solution. So 4 over x squared is equal to 4 times 4x raised to negative 2. Okay? And I will take the derivative of this. So this will be equal to, what will be the derivative of 4x raised to negative 2? That will be negative 8, right? X raised to negative 3. Remember, negative 2 minus 1 is negative 3. Alright, so that's the solution. Or, you could write this further as here at the bottom. You can simplify this one if you will get rid of this negative exponent. Then you will bring that at the bottom, so that will be negative 8 over x cubed. So this will be our dy dx for our solution 1. Okay? But the instruction in the problem is in two ways. So what will be the other way? Okay? So here is the other way. I will use another color, maybe yellow. Okay. So here I will use another color for another solution. Let's say solution 2. Okay. Our given equation is, what's the given equation? This one. X squared y equals 4. Okay, I will directly derive this. So I will have the derivative of x squared y with respect to x is equal to the derivative of 4 with respect to x. Okay, so that's it. So what is the derivative of x squared y? So this one calls for what rule? Power rule? Of course, this is not power rule because we have x squared and y. So this one calls for product rule. So product rule says what? First function times the derivative of the second function. So the first function is x squared times x squared times the derivative of the second function with respect to x. Okay, do not be confused, this is product rule, plus the second function times the derivative of the first function. Our first function is x squared with respect to x. Okay, yeah, equals, what's the derivative of 4 with respect to x? That is 0, right? Because 4 is a constant, so that will become 0. Now, I will simplify further. Okay, so this will be equal to x squared. What's the derivative of y with respect to x? That is dy dx. Okay, plus y times, what's the derivative of x squared with respect to x? With respect to x, and the involved variable is x, so that the answer is 2x. Okay, is equal to 0. Okay, you could rewrite this one as x squared dy dx plus 2xy equals 0. And I will separate the terms with dy dx and without dy dx. So I will retain x squared dy dx on the left side. Okay, and I will transfer 2xy on the right side. This will become negative 2xy. And how do we get rid of this x squared? Obviously, we can get rid of that x squared from dy dx by dividing them by x squared, right? So I will divide by x squared and I will divide by x squared. So this one will be cancelled out and I will be left with dy dx is equal to 1x at the numerator and 1x in the denominator. So I will be left with negative 2y over x. So this is now the derivative of y with respect to x. Negative 2y over x. But maybe you'll be asking, isn't it that when we were asked to solve for two solutions, the answer should be the same? And the first answer that we have previously is negative, this one, negative 8 over x cubed, and the second answer is different, negative 2y over x. Okay, so do you believe that this one is different from this? Of course no, because they are the same. How come that they are the same? Here in the second answer, you will substitute here what is the original value of y. Y previously is equal to this one, right? 4 over x squared. So I could change y to 4 over x squared. So if I will change that to 4 over x squared, this one will be dy dx is equal to negative 2 times 4 over x squared. Question is, where did this 4 over x squared came from? That 4 over x squared came from the value of y when we rewrite the given problem in terms of y, 4 over x squared. Okay? Over x, and then we will simplify. What's the simplification? This is a little bit of algebra. Negative 2 times 4 over x squared is equal to negative 8 over x squared all over x over 1. Okay? And how do we simplify complex fraction? Of course, numerator and the denominator, let's multiply that, and the answer will be negative 8, and x squared times x is equal to x cubed. So this is now our answer for dy dx. So is this negative 8 over x cubed equivalent to our previous answer? Yeah, this is negative 8 over x cubed, and this one is negative 8 over x cubed. So we have solved the given equation using implicit differentiation in 2 ways. Thank you very much. See you soon in the next video.